Okay, we're ready to start the last session of the day here. Again, this is you are between us and the trivia happy hour, so make it good. Okay, so Julie Peppers is a systems engineer at ManTech, and she has a Bachelor of Science in Industrial Systems Engineering from VPI. I'm sorry, Virginia Tech. We used to call it VPI back in the day. And is in the process of earning a Master of Science in Computer Science at the University of Colorado Boulder. I'll let you then introduce the rest of yourself. So, jump to.
All right, thank you for joining this afternoon. I'm going to be talking to you about how I've used artificial intelligence to help with requirements traceability in my role at ManTech. So just a little bit more about my background. When I started my career, it was mostly in project management, event management, and business intelligence. I started at ManTech in the summer of 2018, transitioning over into systems engineering. And in my current role, I'm supporting Marine Corps Systems Command, providing model-based systems engineering support to programs. And the specific program that I'm going to be talking to you about today is the Advanced Reconnaissance Vehicle Program. So where ARV is right now is they finished a couple of prototype phases developing their vehicle, and I'll start by saying all of the images you see in this are AI generated images. They do not actually look like the ARV. That's on purpose. Because it is still in those prototype phases, we didn't want to give any indication of, one vehicle or the other. So these are all AI generated. But ARV has been working on developing a digital RFP. And I'm kind of using air quotes when I say that, because they're still going to be having a standard RFP that goes out through all of their standard processes. But one of the attachments to that RFP is going to be a SysML model. That model is going to include a digital representation of their statement of work, of all of their contract deliverables, and all of their performance requirements, which I'm going to refer to as P specs throughout this presentation. One of the things that my team is doing is developing a logical architecture to represent the problem space that will be presented to the contractors that bid on the RFP. And when however many contractors are selected to perform this next phase of the contract, they will be developing SysML models to give back to the program office as the solution space. So one of the things that I wanted to be able to figure out up front was, in the logical architecture we're developing, which requirements do those different parts of the system satisfy? That way, when the government receives models back from those vendors in the future, we can check, did their actual physical system realize that logical architecture, number one, and did they say that they're satisfying the same requirements that we expected them to satisfy? So a big part of being able to do this work is being able to establish traceability in this problem space model that we're putting out there. So just to get into some of the numbers defining this problem, ARV has over 1,000 P specs. The logical model that we're building is extremely simplified, but it has over 125 blocks representing various hierarchy levels of the system. So, the number one problem is figuring out which blocks satisfy which P specs. We have a little bit of documentation to help us figure this out. We have a MIL standard 881, which defines what they call the work breakdown structure. We're using specifically the ground vehicle appendix. So it defines all of these different aspects of a ground vehicle system. And we also have the performance requirements in a Cameo model. So, bare bones, if we didn't have any artificial intelligence solution, our job would basically be to do keyword searches in that model to find all of those requirements that meet, keywords that we might search representing those system blocks. So on the slides here, I have an example. It's a little bit covered up by the camera view, but you can see I have a system block of a hatch. And that's just one of those 125 system blocks. And if I was going to take a manual approach to figure out which requirements need to be satisfied by that block, you can see I've done a keyword search in the model. I've scoped it to the performance requirement package, but in that one search, I'm getting 13 results. And again, these are artificially faked requirements. None of the requirements you see here are actual ARV requirements, but the numbers are accurate. So searching hatch results in 13 performance requirements, but what that doesn't include is egress or door or exit or any of the other words that might be in a performance requirement that still need to be satisfied by the design of that hatch. So like this says here, the manual method is slow, it's labor intensive, it requires me as the human to know all of the words that I need to search. And I still might make mistakes. I might click on the wrong requirement and then attach it to the wrong system block. And so I started looking for a better way. And so now we're getting into what was the AI solution for this problem. So there's a lot of different ways, obviously, to attack this. We've already heard a lot of different options today of the ways that people are using AI to solve these kinds of problems. In this particular case, I turned to Google Gemini. ManTech has a CUI approved environment where Google Gemini is hosted. In the way that it is implemented at ManTech, I can upload a CUI file, and nobody else at ManTech who's also using Gemini has access to that file. So I'm able to use that for these government files. And so what I did was I extracted certain key fields from my performance requirements out of the model, and I extracted just the Appendix G of that military standard that defines ground vehicle systems, and I used those as my source documents. So what I did was actually I'm using Google Gemini's custom gem feature. So this is my setup for that custom gem. So what this does is it basically lets me create a persona that can answer questions against these files following these instructions. So I'm giving it very precise, well, not very precise instructions, but I'm telling it basically what its role is. I'm saying you're a systems engineer, you want to establish traceability between the system design and the requirements, and you're using these source files to understand the system itself and the requirements. Excuse me. So now that I've set up that gem, I can start asking questions against it. And once the gem is set up, it's just like any other chat interface for an AI service. But every new chat I start using this gem is already using the same files and the same instructions. So it's a one-time setup, but reusable in the same context. So the first thing I did was just develop an initial prompt. I wanted to be as specific as I could be, so that I can, let the chat know what I want it to do, how I want it to use the files that I provided, and how what kind of output I want. So I try to be specific. I'm telling it that the Appendix G describes the composition of the vehicle. In order to let it understand that semantic context of, what does a hatch mean in more than just the word hatch, or any words that I could provide it. I'm also telling it that I want it to give me back a list of requirement IDs. So I'm telling it what kind of output I want. And I want it to match up those requirements with those parts of the ground vehicle system. So I'm asking it to identify a relationship between them. And you can see on the far side of this slide, the initial results that I got. And again, these are made up requirements, but they reflect the subject area of the actual ARV requirements that I got back. So if you're not familiar with the Appendix G of MIL Standard 881, hull frame body cab is actually how that part of the system is called out. So is system survivability. So at a high level, it's doing a pretty good job for the first go round. It found certain requirements that referenced the two different parts of the system, and the results, went on longer than this screenshot obviously does. But you can see it did a good job, but I'm looking for a little more granularity than that because I want to be able to create relationships to all 125 system blocks, not just, you know, a subsystem up here that contains many blocks. So the next things I'm going to be doing or have done in this effort is just iterating through. And I'm looking for a few different things. Number one, I'm looking for correct output. So early on in my use of AI, I just was experimenting with different inputs, different questions, looking at those answers and trying to understand what I'm getting back. And sometimes it would tell me, you know, here's this p-spec number and here's these words, but I would go to look in the document from the actual program and I wouldn't find it there. So it was actually hallucinating data just because I asked it to come up with data. And that's the job of AI. Generative AI is supposed to create new data, but for this use case, I want it to create the relationships. I don't want it to create requirements. So I needed it to be more careful about what it gave me back. The second thing is I wanted to make sure I'm getting the right level of detail. So in the first screenshot of outputs, you saw that that whole frame body cab was all grouped together, but I wanted it to be able to break those down and give me a more granular mapping of the requirements to those system parts. I also want to make sure I'm not missing any output. So, you know, like I said, I have 1,000 requirements and 125 plus blocks. I don't want to get just 10 mappings. I want, you know, probably thousands of mappings. So I'm needing to check to make sure I'm getting the appropriate coverage of my response. And in order to get all of these things, I'm starting to add more follow-up questions to these chats. I'm adding more chats. And, you know, subdividing the data to really get all of the output that I'm looking for. So you can see here an example of one of my refined prompts. I'm not going to read the whole thing because it's a lot longer, but I'm giving it more information about, you know, the whole frame body cab is made up of all of these other parts that are in my model. And the requirements has, you know, all of the data that might be related to those parts. So now don't just give me the requirements for that whole subsection of the model. Give me requirements that map to each individual part based on what you're learning from the mill standard provided. So you can see in the outputs to the right, they're cut off, but the words aren't that important. But you can see now that I'm getting hull and a set of requirements, and hatch and a set of requirements, and towing, lifting, tie down provisions and a set of requirements. So those three, plus some others that aren't shown here, are breakdowns of that whole frame body cab subsection. So it's doing the job. I'm not done here, but it's doing the job that I'm asking it to do and breaking down that data. So I wanted to share some lessons learned through going through this experience because it really taught me a lot. And this is a very kind of a simplified example that will iterate and have, you know, more use cases down the road. But in order to have a successful AI augmentation for a solution like this, number one, you need to have a well-formed goal. I absolutely knew what I wanted out of this project. I knew from, you know, spot checking the data whether I was getting what I wanted, and from even before I came to AI for a solution, I did those manual searches. I started to see how long it would take me to actually, you know, work my way through those system blocks and create those relationships on my own. And so I knew my goal was that I needed those relationships identified, and I needed them much more efficiently than I could do as a human. Secondly, clear, precise instructions. I tried to be as verbose as possible in my prompts, and really where I thought I was being extremely verbose. Since I created this presentation, I've seen other examples of, you know, worker instructions for an AI agent that are paragraphs long. So I even learned myself that I can be much more precise about the instructions that I give my AI to get answers back. The next thing, relevant, well-formatted inputs. So because context window can tend to be a problem where you might fill up the, you know, the memory space of this chat just by your files that you're putting in. I trimmed my files as much as possible. So instead of giving it all of the mill standard PDF, I trimmed out to just the Appendix G, and really just the few pages that went through the outline structure of the ground vehicle system and its definitions. And similarly for the requirements, I only needed name, ID, and text. So I put that into a CSV file, and I got rid of things like, rationale or other related data or other attributes or tags that were included in our, the original data set of those requirements, so that when I'm asking these questions, the AI is able to use as much of that data as possible. Thorough validation of outputs. So like I said, when I first got started on this project, I started seeing fake requirements coming back to me. But I would spot check and look in the requirements file. And if I saw that I was getting, unreal data, those hallucinations that AI can give, I would change my prompts to say, only give me requirements that are from this file, and only choose them based on what you're learning about the system in this mill standard, so that through those, excuse me, through those instructions, it was learning, only the creation that I wanted it to do was the relationship, not the requirements and not the system design itself. And then just refining it through multiple iterations, so that I can keep working my way through all of those 1,000 requirements and 125 system blocks and get that thorough set of relationships. But the benefits of this whole solution, I definitely got more robust data connections than I could ever have made myself. Even if I knew all of the keywords that I might need to use to find the right requirements, number one, it would take me that much longer to do those manual keyword searches, but I might never be able to come up with some of the concepts that I should search to find a requirement that meets the expectations of a hatch on a military ground vehicle system, because I lack the subject area expertise. But the AI can use all of that semantic knowledge from the mill standard definitions and come up with much more robust data connections than I ever could myself. Obvious time savings, just running through those couple of iterations of the prompts took minutes, whereas searching for all of those terms and finding all of those requirements would take hours or potentially days, potentially weeks. And the key thing for me is that, my workload for supporting ARV is long. There's a lot that we can do for them. I would much rather spend my time helping them make strategic decisions, or really making, coming up with more value out of the models that I'm developing, as opposed to just spending weeks just trying to relate two data sets in the model. So it automates those mundane tasks to let me focus on more higher order tasks. And when we can show to the customer the relationships that we've created in this data, and they know this data better than I do, and they see, oh yes, those are exactly the requirements that need to be satisfied when the vendor designs this hatch, it builds their trust in this model. So, ARV has really been taking a leap of faith with us, helping them in MBSE efforts for years now. But they're also, learning, and they're also just trying to get more and more of the program office up to speed on model-based systems engineering. And the more of these value-added outputs that we give them, the more trust that builds in the model, so that as we go through more and more of these contract phases, more of it will be model-based, and it won't just be an attachment to an RFP, but potentially down the road, the whole RFP will be a model, or at least that's the hope. So this is my last slide. I just wanted to add some information about kind of the future of what we see with using AI to do this type of work. The biggest piece is, as the contractors are executing on this contract that's going to be awarded, they are going to be providing SysML models back to the government. And one of our roles will be to help them understand those models, to help them assess whether, the physical model did realize the logical architecture that we designed, whether they are satisfying the requirements that they're expected to satisfy. So we're hoping that using tools like, like this, which is kind of simplistic, or using a tool like Nicole presented in the previous session, where we can actually connect our model to, a semantic data layer and ask questions of the model itself, that we can make that review process be more thorough and less manual. And then we'll be able to answer any questions that the program office has about their models using more sophisticated tools than just our subject area expertise. So that's all I had for you today. Are there any questions?
Yeah, any questions?
Did you find that when you were having Gemini and Mac, the requirements to the systems, that Gemini was generating the same amount of requirements for each system, or was because you provided the spec with the requirements that Gemini had like various amounts of requirements? Because I've had that issue in the past where it's like the same amount of like information under one.
Yes, I know what you're talking about exactly, but that's what I was seeing initially. So I did have to keep refining my prompts, refining the gem, and really saying, like, it's okay if I don't want just 10 requirements for every part. I want the requirements that match. And so sometimes I would get 3, sometimes I would get 15 or 20. It really, I don't think I ever got to 100% solution. Times change, we move on to other projects and things like that. But yeah, I was able to overcome that.
How many times do you think you probably did like adjustments to your prompt to get like a suitable output from Gemini?
So it's kind of like a two-sided answer, because just to get the right kind of answers, maybe it was like 5 or 6 or even up to 10. But then once I got that right prompt, I found that the data set was still really huge, so I would subdivide it. So then I would have to kind of like go through the same set of prompts, not as many because I got better at asking the right question, but I would start a new chat and maybe just focus on, this one part of the ground vehicle system, instead of just trying to ask it to do the whole thing, because I was never going to get all of that mapping in one output.
So did you have to create new chats?
Yes.
Yeah, I could see how Gemini becoming.
But the good thing about the gem is the setup is one time. So I can, just like, I don't have it pulled up here to show you, but they have a coding assistant chatbot. They have this chatbot. You're basically creating your own chatbot when you set up a gem. So then I can just click on that gem to start a new chat. And so I don't have to add those files again. I don't have to revisit those instructions again. I can just start a new chat with those source information.
Thank you.
So the thing you're talking about is like where you get stuck with that top K results. You get like the top 10 closest matches. Even if there's 150, you're only going to get 10 across the board or whatever. And and I think one of the things that you see, because you're using sort of that monolithic AI, right? And one of the things that Mario and the team have been discovering is that as you start to use something like the FlowWise, where you have, an agent that's an LLM instance, right? And it specializes in that task, this task, and that task. So like you said, you limit the data it has to work with, you limit, what you're asking it, so its mind doesn't get blown, quite literally. And then you can also turn off some of those restrictions so that, you're not going to get, cut off at the knees, either with like just the top K results or, like token limits and things like that. So you can really expand the resources, of the team of agents, so that the results you get are going to be the results you're really looking for.
Yep.
That's the main.
Additionally, our strategy is to sort of append the result from the previous result. Sometimes we'll summarize and simplify, and then with the customization of the agents, we can actually increase the K return to top result and increase that number to increase the number of results returned. combination of those strategies and a little bit of tuning, that helps make sure that we have it.
So
Yeah.
what you're saying is you're gonna be building some custom agents. as
Well, actually, we have started building this agent. The only reason that I didn't use the agent for ARV is because at the time we were on this project, it wasn't ready for that FlowWise environment wasn't suitable for CUI data. But what we did was we basically used AI to create fake requirements for fake ground vehicle systems, feed it that same Appendix G, and train the agent so that we could do the same type of mapping. So that is something that has been done.
It's like the next generation.
I think that's more specifically the NDA and trying to.
That too, yes. Yes, so our environment has, beyond just contractors, which, most of the data we were working with was distribution DE limited to DoD contractors.
But we're still using Azure Gov, which would be.
Right, okay. Thank you.
Okay, so we're getting ready for next session. Thank you, Specs.
I touched the button on the side. I don't know what it is on this side. Okay.
Okay. So 1 down, 2 more to go before happy hour. And Jerry winning the trivia contest. Which is, you retired? Okay. Yeah. Oh, good. I think that would be great for the trivia contest.
Oh, I love trivia. I don't know if I'm good at it though.
Okay, so let's see if we can by the way, you can hide this if it gets in your way. You can hide this and just move it around.
Okay,
Okay. Let me just this up for you. Oh, this is not you, right?
that's me.
Oh, it's just you. I'm not awake. Sorry.
Yeah.
There we go. We're good now. Okay, I'll introduce you and we'll start it for work.
Okay. Do I need the mic or is everybody gonna be
Yes,
here?
you'll need to like because people are not. So.
Cool.
So just flip it where it's a good spot for you.
How's that?
Perfect. That works.
Okay.
That works.
Cool. Do we have a couple minutes or am I starting now?
Yeah, we want to start this again. People might be coming in from the other session. Okay. So we will have part 2 of the ManTech session in a minute. This turned out to be ManTech track. By the way, I'll let you guys in a secret how we did this. So your abstracts came in and the team on the steering committee went through and prioritized them. And so what we did was pick as we went through the list, as we were building it between the 2 sessions. Okay, one started here, or started that one actually, and then the other would come here. So 1, 2, 3, and we just went all the way down the list that way originally. And then of course there were some people who changed and adjustments and things like that. We had to make some adjustments, but in general that's what was done. So kind of priority. So anyway, I guess we're not quite there yet.
So we got day 2, does that mean you were just kind of?
Yeah. All my stuff was on day 2, so.
Oh, okay.
Doesn't
matter. Sorry, John, we'll still be there for you tomorrow. I'll be hungover after.
Exactly, yeah. That doesn't mean they were right. It was just that's what we did.
Ask the AI to prioritize.
Yeah, we should have done that. We'll do that next year. So, of course, it's the training of the AI is to get to prioritize things correctly would be good. Huh? Oh yeah. No, try not to make it my priorities. In fact, I think pretty sure I recused myself from that evaluation, by the way, because I had a lot of my folks giving in stuff too, so I didn't feel it was appropriate.
Fine, I'm used to it.
Just wait for you to say something.
I'm waiting for Steven to say something.
Yes, I'm sorry. Gotta run the trains on time, guys, so. Okay, so, we're gonna introduce, Shallu,
Darhele. Darhele.
Darhele, okay. Is a model-based systems engineer at ManTech. She has a bachelor's degree in systems engineering and operations research from the George Mason University. She currently supports both USMC and Army contracts, has contributed to significant time savings using her knowledge in computer programming to automate modeling tasks. Shallu.
Thanks, Steven. Yeah, hi everyone, I'm Shallu Darhele from ManTech, and the subject of my presentation is automating the management of large data sets using computer programming with AI. Let's talk about me a little bit more. I'm a model-based systems engineer at ManTech, and I'm a part of the digital transformation team. I have a bachelor's degree in systems engineering and operations research from George Mason and continued education in MBSE from MIT. I'm also a certified enterprise architect, thanks to Kevin Brett, who actually led the course. And I also dabble in some computer programming. I'm most familiar with Python and Java, and at ManTech, I've been given the freedom to pursue coding and a lot of the efforts that we're part of, which leads to my discussion today. Today, I want to talk about a practical application of AI in systems engineering, specifically how we can use it to streamline the often tedious process of importing requirements and other data into our models. As systems engineers, we're constantly dealing with large amounts of data, and requirements are a critical part of that. They define what our systems must do, and they form the foundation of our models. So think about just the sheer volume of information we handle: specifications, design documents, test procedures, etc. All of this data needs to be managed efficiently to ensure the success of our projects. However, the traditional way of getting these requirements into our modeling tools can be really time-consuming. Manually copying and pasting each requirement is not only tedious, but it also introduces some risk of errors. So we need a better way. We need to find efficiencies in our processes to free up our time for more complex tasks and more creative engineering tasks. And that's where AI automation comes in. To effectively manage this data, I often rely on a combination of tools. This includes the standard Microsoft Office suite, Word, Excel, PowerPoint for document handling, Visual Studio Code for writing and editing code, Python, obviously for scripting, and most recently, Mesa, ManTech Enterprise Smart Assistant, which is our AI-powered coding assistant at ManTech. And in this presentation, I'll share a specific example of how I used AI and Python scripting to automate the import of requirements and how this drastically improved my workflow. All right, here's our challenge. To give you some context, I was brought in to assist a team member on a fairly matured project, which involved a 400-page statement of work document. This document contains a wealth of information, and one of our major tasks was to extract and import the almost 600 individual requirements into our Cameo Systems tool project. I think there was, like, to be exact, like 580 requirements, something of that sort, so rounding up. And it's a lot. That's a lot of requirements. So my first question to my colleague was, how are you getting these requirements into the model? And the answer that I got was, it was just a lot of manual work. Like, you have to read through these 400 pages, meticulously copy and paste each requirement, its ID, its name, the description or text, and just like 600 requirements, that's gonna take days, if not weeks, to do manually. And it hadn't even been done yet At the time, there was only a small sample size of the requirements copied into the model. For obvious reasons, it just wasn't feasible to drop all of our tasks, all of our other tasks, to spend all of our time copying the requirements. So not only would it have been incredibly time consuming, but the potential for errors, typos, missing requirements, formatting issues, that would have been really high too. Oh, not to mention that this isn't a one-time job either. The statement of work document that we received and that we are working with is continually evolving, and it's being refined by our customer. So we've already received multiple iterations of this draft document, and we continue to do so. So it's still to this day in draft form. So having an automated method to manage the data and extract the information that we need from this document is crucial to the success of our support to the program. So each iteration requires us to repeat the extraction process, which, when you think about it, when we're automating it, amplifies the savings that we're achieving through automation. So it was clear to me that I needed a more efficient and reliable solution, and I knew that automation was key, and that's where Python came into play. So the solution I came up with was Python scripting with Mesa, ManTech's AI-powered coding assistant. Python is a simple yet powerful object-oriented programming language. It has countless numbers of useful public libraries, which are just collections of pre-written code and functions that make programming easier and simpler for us. And it's more than well suited for handling tasks that deal with large data sets that require data analysis, data cleaning, data manipulation, etc. With Python's ability to read and write files, you can write scripts to parse through documents, extract specific text or lines of string from those documents, and format the information as needed. And in this case, I knew I could write a Python script to read the statement of work, identify the requirements, and extract the relevant information. I'm not an expert in programming. It's just something that I like to do. But I do have a pretty good intermediate amount of knowledge in Python. So I can get by with writing a script here and there, but developing the script from scratch would have taken like a considerable amount of time and effort. And so that's actually where Mesa proved to be like a major game changer. So Mesa's software engineer persona specifically is designed to help developers write code more efficiently. You can provide Mesa with natural language prompts describing what you want the code to do, and it'll generate code snippets for you. It's like having an AI-powered programmer partner that can like quickly generate boilerplate code, handle the repetitive tasks, and suggest better solutions. So this allows you to focus on the higher level logic and the specific needs of your application. So instead of spending hours of writing every line of code myself, I used Mesa to accelerate the process. So I gave Mesa prompts like specific prompts, like write a Python function to open a Word document using the Python docx library, or write a regular expression to find lines that start with the letters REQ followed by a number of digits, and then use those digits as the requirement ID. And in the example on the screen, I prompted Mesa to print the amount of time that it takes to run the code. And it took a couple seconds to think about it. Then it provided me with an explanation on what is the best suited method or module within Python to use. And then that is followed by a block of line-by-line code that I could just copy and paste into my script and run. And then it also explained what those lines of code would do and the kind of output that I should expect to see from it. So I now have like the building blocks of the script that I need to use to do what I want it to do. And that allowed me to focus on the overall logic of the code, as well as customizing it to make it more accurate. So this significantly reduced the development time and allowed me to leverage my Python skills a lot more effectively. it was like having a knowledgeable assistant who can quickly translate my like pseudocode ideas into actual code. I also use Mesa to help me with more complex tasks, such as handling different document formats and extracting data from tables. And Mesa provided me with code snippets and suggestions, which I then integrated into my script. Another benefit of using Mesa is that it helped me troubleshoot errors in my code and suggested more efficient ways to perform certain operations. So instead of spending a bunch of time Googling the errors, I just and having to sift through the different websites and forums, I just copy and paste the error that I receive into the chat box as a prompt, and Mesa would help me debug my code. So this speeds up the development process and also improves the quality of the final script. So here's our output. The script that I developed using Mesa's assistant not only extracted the requirements. Well, okay, so we started off with just having it extract the requirements. And then we very quickly realized that we can have it do so much more. So you deliver something and it works great, and then your customer's like, oh, okay, well, can you do this too? Can you do that? So we went from pulling requirements to now also formatting the data in a specific way to facilitate easier import into Cameo. So the script's output is an Excel file. Each requirement is organized into rows, and I didn't screenshot all of the requirements because it's data that I can't share, but I can show you the columns. And those attributes are like the requirement ID and the name, the description. Those are all placed into separate columns. And so this structured the format of the data that was given to us in an unstructured Word document. And the format is crucial for Cameo because Cameo has an import function that allows you to bring data directly into the model through Excel files. So by generating an Excel file with Python in the specific format that we needed, I eliminated any need for manual manipulation after the extraction. So we can simply import the file into Cameo, and all 600 requirements are easily populated into the model accurately and efficiently. So this step saved us hours of tedious work, and it minimized the risk of introducing errors during the import process. Okay, the benefits. So there are a lot. I only listed a few, but I'm going to go over some more than that. Significant time savings. So the most obvious benefit was the dramatic reduction in time required to import the requirements. What would have taken days or weeks manually was accomplished in a matter of hours with the script. And it's crucial to understand that many projects, including mine, we're not dealing with a static document. It's ever evolving, it's always changing. So we're going to get iterations and iterations of this information. So multiple iterations, exponential savings. The statement of work, like many other documents, go through numerous revisions, and we have received multiple drafts from the customer requiring us to extract and import the requirements again. So this, where the multiple iterations come in, I think is where the power of automation truly shines. Automated data pipelines. We can often pipeline these scripts. So instead of using just a single script, we can create a series of scripts that are interconnected, which form an automated data pipeline. So one script extracts the data, another one transforms it, another one formats it for import, another one pulls out all the acronyms, another one pulls the relationship of procedurals to requirements. So there's a lot that we're able to do with just writing a simple, I shouldn't say simple, but a Python code or a script. Reduce manual effort. This freed up a lot of mine and my colleagues' time to focus on other important engineering tasks, such as analyzing the requirements designing the system model, collaborating with the stakeholders. And so we're able to contribute more strategically to the project. Improved accuracy and consistency, automating the process, minimize the risk of human error. And we actually caught a lot of errors too. We caught a lot of redundancies, misspellings, I think like repeated requirement IDs that should not have been the same. So it leads to enhanced data integrity. By reducing errors and ensuring consistency, we improve the overall quality and the reliability of the data in our model. And finally, increase productivity. So by automating a repetitive and time-consuming task, and especially by automating the entire data pipeline, I was able to significantly increase my overall productivity. This allowed me to accomplish more in less time and contribute more effectively to the project. So I can't tell you or estimate or give you an exact number of how much time I saved, but I'll just throw out save more than 80% of the time doing all this manual import. That translates to a substantial cost savings and huge increased productivity for the project, a much higher level of data quality and consistency. So in conclusion, my experience demonstrates the immense potential of using AI-assisted Python scripting to streamline data management and systems engineering. Tools like Mesa and even Gemini and other AI tools can empower engineers to automate complex and time-consuming tasks, which frees up their time for more valuable work. By embracing these technologies, we can improve our efficiency, accuracy, and overall productivity, which leads to better engineering outcomes. And I encourage you all to explore how AI can be applied to your own workflows and to look for opportunities to automate repetitive tasks and leverage AI to your engineering processes. The future of systems engineering is definitely intertwined with AI, and by embracing these tools, we can unlock new levels of innovation.
Right on time and actually a little ahead, so we have plenty of time for questions. Bill? Just like,
I am. Like the wind, at least in the short class. That was a very good presentation. I did have one question. How did you handle these requirements, the initial requirements, which oftentimes are vaguely worded, inconsistent, misspelled, they inform languages, etc. Did you have to worry about or have a technique for taking requirements data?
I'll be candid, that was not our task. It was, the requirements were already made, and the point of what we're trying to do is, I don't know how to put it in a way that doesn't sound like sales pitchy, but we're trying to sell model-based and digital engineering to our customer. So.
Have you thought about using AI to automate or streamline other processes?
I've thought about it. Have I had opportunities to apply it? No, but definitely open to it. Yes, absolutely.
Yeah, I have a question. So I'm curious how you compare what you're doing, what we do in Slate with our import analyzer, because we import Word documents pretty routinely, and we actually separate the requirements from statements. That's a keyword check, but that's again using regex. So we're doing NLP checks and things like that with it, and then you can export it as a CSV file if you want. So
yeah, that's what with our Cameo model. So we don't have
you're using old tools, it's a problem, can't you? That's the problem.
Yeah,
Running into, and I gotta tell you, we keep seeing this over and over, where the tools that people are using are just so old, they're not looking at the modern things that are out there. So a lot of other solutions. I've been doing parsing, we parse maybe tens of thousands of documents over the years, so.
I'm sure there are other ways. We were
Yeah.
just, this is something that we came up with the tools that we had available.
Yeah, it's always the case when you're stuck with what you got do what you can.
Right.
So, yeah, I understand. But do take a look at some other things like that, because there's just a lot of good stuff out there.
Yeah, it's great advice. I will, definitely.
Steve,
Yeah.
quick comment. I would say though that, you know, when you're talking about processes, for example, I mean, there's automating processes, but first you have to even know what the process is in the first place, right? It's good, bad, or ugly, you know, so what is the process? And one of the things that the team is looking at, you know, we've talked with Mario about, he mentioned earlier about interviewing people, you know, to get information from them, to get the stuff that's not written down, you know, in a book or an SOP or something like that. And there are, unfortunately, probably across industry, right, there are probably more undocumented processes than documented. And so one of the things that we have, like with Marine Corps Systems Command, is that there are certain key processes that you have to get, or certifications that you have to obtain. Your system has to be certified for safety, for transportability, for, cybersecurity certification, et cetera, et cetera. There's literally about a dozen of them. And unfortunately, those processes are not, you don't have a book you can pick up to go, oh, here, we're on step 22. I need to go talk to Fred, because he's the guy that's the expert on step 22, and he's going to tell me how this all works. So what the approach is, it goes back to something I did back with that smart flow system that I mentioned, where we had to interview the air traffic flow managers. We had the rule sets that define how traffic flow management works. What we didn't have was all of their expertise and all of their historical knowledge that's stored up between their ears. And so we had to interview them and then keep modifying the system until it would produce the same results, because it was using the same rules that they were using. They were just forgetting to tell us certain rules, right? So what Mario's team is looking at is interviewing the people that are the humans that do the different parts of, process X. So maybe there's you four people over there are the ones that know the process, but no one person even necessarily knows everything about the whole process. So you go and you interview those people, and you talk in terms of like, what's the first phase and the second phase and the steps within the phases, and the inputs and the outputs, right? What happens during a certain process step. So you're getting a structured interview, and that person just babbles on. And oh yeah, but if it's a Tuesday afternoon, you have to do it this way instead, for whatever weird reason. So you interview the person, and you're captured that. Think about it. You capture that with just a recording, right? And you do text to speech. So now you have a Word document. You got all of that sort of interview, right? Captured as a Word document. Now you can take that and feed that to a RAG agent. So you just gave all of that knowledge from those different sources, those different people, plus any written SOP, if you do have written documentation, you shove all that into your agent. So now that agent's an expert on that process. It knows everything that all of them know combined, and then some. And so now when you're working through something, you can start to ask it questions about the process. Okay, well, I've got this and I got that, and I'm at this point and I did that. What do I do next? And it could walk you through the process. So if it can walk you through the process, it could also turn around and now, put it out like in a simple tabular form. And it could formulate it for you, right? Here's step one, step two, the inputs, the outputs, who are the performers, et cetera, et cetera. What are the rules? What are the decisions that get made, sort of like a verbal flow chart, if you will, right? And so you could take that information if you wanted to see it as a flow model and, put that into whatever tool, like Cameo, so you can actually see the diagram along with the narrative of what happens in all those steps, because you teased it out of the humans. And then you got it into that more rigid form, or codified form, so that now when you get new people coming along, here's the SOP, train them up on it, so before you can automate the process, you have to know where it is. But that's an approach to getting toward it. I'll get back to it, you on Zapata. Where we did that for NASA. I saw that. Okay, any other questions? Let me make sure there's nothing online there.
We go good. It doesn't look like anything on chat, so anything else? Any questions? Okay, let's thank you again. Thank you. Okay, we got 5 minutes before our next presentation, which will be the last of the day. So well, everybody's excited, I'm sure. Let's see now. What did I just do? There we go. Erika. This really is the ManTech session. I don't know how it happened by accident. I will tell you this, that this happened this way. You just had guys had a lot of good papers, I guess. The by the way, the one next door is the spec session. All the spec people on that one, so it's kind of weird. We probably should have, but it just the way it worked out. It just was we just left it. So actually, no, I moved the spec people in that slot because they have to be at a presentation, another conference tomorrow, and so they were set up for tomorrow, and there was another group of us, Amir and I think we're doing this session there would have been so we moved ourselves to tomorrow. So.
Okay, so will you help me get set up here?
You should be all set.
Rolling.
Yep, and we just
Ready to
need
mic?
your mic. Yeah, it's right here.
Thanks, sir.
Testing 1, 2, 3. Testing. Yep. And it's just like close. Okay. You got water, so you're good.
I'm good, thank you.
Okay. Is anybody else tired? It's been a long day. Yeah. Okay. Good.
Started at 4:30, is that right?
Yeah, 4:30. Yeah, on it up. We try to keep the brain running all the time. I actually like him run along in the morning with the warning talking about it. I thought he did the time.
This one's the
Mark having a name like Sharp.
In what aspect?
So everybody
The
say
joke.
you're a Sharpie, you're too sharp
Too
for
sharp,
this.
yeah.
You know?
And my husband has it worse because he's in the Marine Corps and so
Oh.
it's always, you know.
Oh yeah. Oh, he must have what's his call sign? Yeah. That may be just for pilots.
Well, it's funny that you would say that.
They usually nickname you though, so.
Yeah,
Yeah.
it's Sharpie.
Sharpie?
Yeah.
Yeah, of course. They're not too creative.
I mean, sometimes they are, and sometimes it's mean.
Yeah.
You know, it's usually like when
Yeah,
someone
very
messes up.
That's usually the idea.
Right. Gentle bullying.
I've been living in a suitcase last month.
Well, where's it going?
2 weeks ago, DC, last week, No. Get back into my routine.
Okay, I've got 4:30. Let's start from the last session of the day, last paper of the day, I should say. We have a session tonight, which is the trivia hour, happy hour, sponsored by Lone Star. So I hope again everybody who's online can join us for that, because it's actually been a lot of fun every year we've done it. So okay, so let me introduce Erika Sharp. She's been a data analyst for ManTech for over 2 years. She holds a Bachelor of Science in Psychology and Master of Science in Counseling. Well, that's very helpful, I'm sure, in a large corporation in this business, let me tell you. Prior to her role at ManTech, she spent 10 years studying research and analytics of human behavior in the private sector, as well as in geo and human specialties within the DoD sector. Okay, that's intriguing. Erika?
Hi, my name is Erika Sharp. I'm a senior data analyst with ManTech International. I've been with ManTech for about 3 years, working to enhance the strategic and development and utilization of generative AI in support of DoD objectives. Today, I will talk to you about AI-driven development of capability viewpoints for MagTaf command and control. Essentially, my coworkers have given a great description of how we have begun to utilize AI to augment the very time-consuming processes that we have found. So I will continue on with that. I already spoke to myself. So my purpose or problem statement at the time was trying to develop a CV2 for the MagTaf command and control. It was essentially very time consuming, and one of our goals was to leverage AI to generate a data feed for the capability taxonomy model, which allowed for the very overwhelming task of analyzing multiple documents, matching it to or mapping it to thousands of functions and trying to build a data feed so that our architects could build the model. Undertaking this it took a lot of meticulous identifying, defining, and interrelating various capabilities of the MagTaf, and historically this endeavor demanded extensive amounts of manual effort, subject matter expertise, document analysis, and iterative refinement to ensure accuracy and completeness. The solution to address these challenges, our research leveraged AI to enhance the efficiency and accuracy of developing the CV2. By utilizing ManTech's AI LLM, MESA, which we've talked about a couple of times, we were able to streamline the data processing and enhance the reliability of generating the taxonomy models by automating aspects of the development life cycle. This is an example of the CV2. I'm not sure how many of you are familiar with it, but we also worked with, and I'll show you on the next slide, we worked with 3 major Marine Corps doctrines, which was the MCWP 330, which essentially describes the employment of the major C2 components through clearly defined procedures managed by a battle rhythm process. I worked with the Marine Corps Concepts for Control and Command, which outlines the Marine Corps' approach to C2, emphasizing the need for a flexible, responsive, and integrative C2 system. And I worked with the Force Design 2030, now just called Force Design, which focused on transforming the Marine Corps into a more agile, efficient, and technologically advanced force. It focused on the need for modernization, force sizing, and composition to meet future challenges. Traditionally, human digital architects and modelers, as well as analysts, would manually extract and map key capabilities. You're likely familiar with how this approach is labor-intensive, error-prone, and lacks the agility required for contemporary military operations. Manual approaches can sometimes lead to inefficiencies and potential inaccuracies. In the dynamic and evolving nature of the military operations, thrive with more agile and responsive approaches. In this, you'll see a picture of the elements of the ManTech architecture, the meta model of key elements. This is an example of one of my Mesa prompts that delivered the output of the data feed, as well as the ManTech level model that we're developing with AI. Our research objectives were to leverage AI to automate extraction and mapping key capabilities from the multiple doctrines, and reducing time and effort. To utilize AI to ensure accurate and consistent mapping capabilities to relevant joint common system functions. This is a list of over 1,000 functions. And we also utilize the MAR-Core SysCom model reuse library. We look to create detailed hierarchical mapping capabilities, illustrating the parent-child relationships and interdependencies, providing detailed insights into the capabilities and their relationships, ensuring current and relevant updates in dynamic operational environments, continuous collaboration and information sharing across different security levels, domains, and organizational echelons. And last, we looked for identifying capability gaps and prioritization of resources, as well as showcasing the potential of AI in transforming the traditional systems engineering process. Our methodology centers on an AI-driven approach using our ManTech Enterprise Smart Assistant. MESA is a large language model developed by ManTech. It's designed to assist users by providing information, answering questions, and performing various tasks based on its data. Its training data. It's capable of understanding and generating human-like text based on the input that it receives. It's a valuable tool. It's something that we all had to utilize and recognize the limitations, the iterations, and as I continue, I will speak to, at this time, we were just introducing our AI analytics to this concept. Moving forward, I'll talk on where we are now and how our use of FlowWise and agentic AI has really moved things forward. But in this use case, we ingested the validated documents mentioned previously into Mesa's RAG architecture, but specifically in the My DocuQuery settings. So in this setting, you can ingest multiple documents and have it look at all of the inputs in terms of not just like a simple query of this word or this phrase, but to look at it with a more intellectual focus. It does have a limited constraint output. There are some token issues where we found that chunking worked a lot better in order to get a more robust output, because it does use a top K parameter to ensure relevant responses. So the process involved knowledge representation. So the AI algorithms process the input of the documents to extract and represent knowledge about the ManTech capabilities themselves. Taxonomy development, the AI constructed a taxonomy of these capabilities, organizing them hierarchically. The hierarchical structure understanding, recognizing that it needed to be placed into a parent-child relationship. The mapping, AI was able to not only recognize the capabilities, but map them to the system functions that I talked about, the JCSFLs, against the additional information within the MAR-Core system, SysCom model reuse library. And the approach enabled a dynamic mapping process, categorizing C2 capabilities and organization of the data into structured format that not only established the parent-child relationships, but it also illustrated the interdependencies of the capabilities. So this is an example of the data feed that was created with the use of MESA, analyzing all of the documents. It provided the top level parent capabilities, as well as the child connections and the sources, which I would then go back and validate, make sure that I could go to the actual source and say, hey, on page 7, I know this came from here. And that comes from, that human interaction for validation. A key part of the process was categorizing the capabilities into operational activities and aligning them with specific system functions and systems. This structured approach, for example, provided a mapping like a parent capability, such as enhanced situational awareness, to child capabilities like real-time data collection and information fusion, and then linked those specific systems. The hierarchical approach is crucial for illustrating the interdependencies of the capabilities within the C2 framework. The part that was the most important was the ability of AI to provide this dynamic mapping process that categorized the C2 capabilities into their primary function and subcategories of their hierarchy, but being able to see it in this tabular output. So I can hand this to an architect or a modeler and provide them with everything that they need. And I did it in a short manner of time. This is an example of a taxonomy of the C2 capabilities. This only goes, I guess this goes one level deeper than what's actually shown here. This slide provides a visual representation of the capabilities modeled in Cameo from the AI developed data feed. Although not all systems shown here, this model is linked to the specific capabilities it provides, as well as each function is linked to the system that performs that function. Because the mappings exist in the data, it enables traceability, and in this context, obviously meaning being able to follow and understand the relationships and interdependencies between different elements of the model. So you can trace a capability back to the system that enabled it, trace the system to the capabilities it supports, trace the function to the systems that perform it, and trace the system to the function that performs it, or that it performs, I'm sorry. So in essence, the underlying data structure allows someone to analyze the model and understand how different parts of the C2 architecture relate to each other, even though the specific relationships aren't visually represented on the current slide. So our AI-driven approach has yielded significant improvements. As we've talked about, my coworkers have talked about the automation of repetitive tasks, enhanced accuracy and consistency, improving efficiency and speed, advanced analytic capabilities, supporting decision-making, enhanced scalability and flexibility, and adaptive modeling. The benefits can be seen across the board, and the AI-driven CV2 provides a structured blueprint that enhances strategic decision-making and situational awareness, both critical for mission success. It augments the work of systems engineers, and this enables professionals to concentrate on high-level strategic activities that leads to more effective and efficient development of complex architectures. The importance of having a strong data feed for building the CV2 and the process that the AI enabled was reliability of comprehensiveness and improved decision-making in real time, which contributes to a more successful and effective command and control operation. While AI offers a significant advantage in terms of efficiency and accuracy as well as scalability, specifically in this case that I'm speaking on, it's important to be aware of the potential limitations. Addressing these limitations requires careful consideration of data quality, contextual understanding, transparency, ethical concerns, integration challenges, and resource requirements. By acknowledging and mitigating these limitations, organizations can benefit from AI while minimizing the potential risks. So this is what I was referring to earlier. We have now moved on and are way ahead with the process to be able to use agentic AI instead of just LLM Mesa. So as I'm moving forward, I'm taking the logistics capabilities and again, mapping them to the JCSFLs in order to build the same type of data feed, which has actually been more diverse and enriched. And we've gotten, I think, 4 levels of taxonomy for the capabilities by using the FlowWise agents that we've been building. And so I definitely think that as we're moving forward and integrating higher level AI, we'll be able to provide a higher level output. But the positive of it is, identifying the strengths and the weaknesses, able to give the analysis to our SMEs to be able to say, hey, this is exactly what we're looking for, or, we kind of want to look at a different approach to how we're mapping things. In conclusion, our research demonstrates the transformative potential of AI in enhancing all of the complex systems architecture, underscoring the value of the augmentation of the work for systems engineers, architects, and modelers, leading to reliable, timely, and precise architectures that meet the dynamic needs of the military operation.
Okay, are there any questions? Okay, just a second.
So,
Wait.
war is messy, so I was in the companion sister service, the U.S. Air Force. And you have a lot of uncertainties, the enemy does unexpected things. How do you, you could have the best planning in the world, and then all of a sudden, things go sideways.
Sure.
How do you see AI being able to respond in real time to the changing circumstances of the battlefield?
So I think that's a great question. And this is just going to be from my opinion. But I think that one of the benefits of AI and some of the things that we've been working with are building personas and, like we talked about, digital twins. And so what knowledge we do have, being able to put into, we'll call an enemy agent, right? And bouncing off, war game, like table war games and things like that against the information that we do have, which does bring back, again, limited by what we know, right? Of course. But you're able to reference. Is that not your question?
Yeah. All right. So, yeah, sort of. So I've been in war games where we fought a war game against the North Koreans.
Mm-hmm.
These bunch of Navy guys, there might have been some USMC people in there. They surprised us. I was Blue Force and they were Red Force.
Okay.
And they surprised Jesus out of us and actually won a battle with some unexpected things
Right.
happening in the war game.
Yeah, but I think that the use of the AI, you put in the information that you do know that seems reasonable, you combat it with the problem at hand, and it gives you back a result. You don't know what you don't know, but you can build it out the best you can to be a representation of, we'll say, the other side, right? And so that's what I think the agile dynamic of utilizing AI for our military is going to, I mean, it already is very life-changing. Yeah, for sure.
Other questions? Don't make better off of that easy.
Yeah, just like this could go, it's supposed to be unique environment. Yeah. You're in kind of a unique environment, and when I was in the Marine Corps, we used to get in trouble with Don, the Department of the Navy, he was in
They
the
do.
Marine Corps. So, my question would be, that's kind of a unique situation, but it does happen throughout companies where you've got this element behind you that usually leaves you alone unless they want to ruin your afternoon. So do you see the need or the potential for an agent or something that would handle requirements coming from an authoritative source? Does that make sense? How do you handle what part of the Navy would put down in the Marine Corps that would impact your model?
I'm not sure that I am the one to answer that question. I'm gonna let the rest of my team maybe speak on it if you have any concepts that will address it.
Speak a little bit to it because it speaks to. That was a risky move. So just thinking of it from a command control standpoint, you speak to this a lot, in the sense that we're looking at control, especially within the Department of the Navy, the Navy and Marine Corps team is forced to be harmonious because you're looking at a Marine Corps that's transforming into a more expeditionary. And in that transition, the need to communicate between the Navy and the Marine Corps as a arguably the largest team that we've had since World War II. And so, yes, there are mandates coming down for communications and integration of those communications from on high. But I think everybody is looking at it, it's like, oh yeah, that makes a lot of sense. You do need to think about that. The Marine Corps has a great history of improvise, adapt, and overcome. Speaking of war games and things like that. But that's also the alone and unafraid mindset, where you have to have that skill set in your toolbox, but you also have to realize the integration in your loop for command control is so critical. So I don't know if that answers your question.
It's just this corporate
Oversight or,
there's places in corporations that would have the same kind of environment.
right,
So you build all this stuff, suddenly for someplace else, how do you do it within a model? See if this stuff does come. So an agent or something.
You're talking. No, you're not. No, do it again for everybody else. And for the recording for posterity.
Second try, maybe I'll get it right this time. No, in the real life, in the real world, corporations have this kind of stuff.
right.
So, and if we need some way within this, if we built a model, we got things kind of understood, we manage your requirements, but suddenly you're getting hit with a level of importance that I don't think you can just add it to your requirements. You've got to deal with it in a different way. At least I think that's how I would approach it. So that was my question too. If it's not just a requirements change, but it's a the C2 or a command control change, how do you deal with it if it's the model? And then you have the answer.
I'm not sure that I have the answers to that. I mean, I know that we make iterative changes to our agents constantly based on, again, not just new requirements, but limitations or additions or anything like that. So they are scalable. I mean, that's the whole point, is that we can make those changes that are required. And I keep saying requirements, but that's not exactly the word that I want. But Kevin's looking at me. I know he wants to say something, so I'm gonna let you go.
I was listening.
I know.
I didn't want to cut you off.
No, I don't feel cut off. I also,
No, I
we have 5 minutes, so.
that, to wrap up, I think we're talking about our conversation kind of split in two directions, which is cool because they're both good and they're both important. To back up for a second, the purpose of what the work that Erika was doing was that, you know, if you get like a Marine Corps publication that is the textbook for command and control, this is what they teach them in school, right? Strategic, you know, there's a whole tree, a family tree of documents. And you start it with command and control. You start with logistics, like what is logistics in the Marine Corps? Strategic logistics, operational and tactical. And it goes down, you know, down many levels below ground from there, right? And we're trying to build a model of the Marine Air Ground Task Force, like kind of a static. So you think of it as a bit of a digital twin. It's not connected to a real model. But we're trying to build a digital model of the Marine Air Ground Task Force, not a bunch of one-off stovepipes that you have to look at in isolation. So we're building this big integrated model. So as a key part of that model, we're looking at the capability layer, okay, to start with. And then all the, like she was talking about, all the systems and everything kind of hook into that. Like Nicole mentioned, the CV6, you know, talking DODAF speak, you've got your systems mapped to your capabilities. Okay, and then she also mentioned she's doing similar work with mapping a different agent that she's using to map the joint functions, common system functions, and there's about roughly 2,000 of them. And it's not a real complete list, but it is what it is. And we have all these functions and we have all these systems, and yet we don't have architectures for all these systems. So at the very least, we need to know what the heck they do so you can compare apples to apples. So if you can take these systems and you can have the AI map the joint functions to the systems, that's a start. That's a first pass at saying, hey, what does this black box do? I don't care about all the internal workings of the watch, but what does this black box do from, you know, from like an operator's perspective? Okay, so now I've got functions, and I can take that, you know, the functions are down here. This is the system, and I can take this system and I can map it to the capabilities above it. So we know from a capability perspective, you know, what it does. So now we've got like several layers architecturally across the entire, all the warfighting functions of the Marine Corps that we didn't have before in a model. We got an enterprise level model. And now we can take that model, we can shove it into simulations to do different kind of simulations, different pieces of it. And then when you talk about requirements, some of the agents that we're working on have the ability to do like strategic level requirements, like you load in the Commandant's planning guidance, the Commandant of the Marine Corps. You know, it's I forget how many page document. This is the vision from the Commandant. You load in a bunch of his speeches and a bunch of interviews that where he is talking about, this is what I want my Marine Corps to do. This is what we must do. And some of that includes direction coming from on high, you know, from Department of Navy or the White House or you know, wherever, right, SecDef. All that trickles down, but then you can take that information and now you can take system requirements and portfolio requirements, and you can start to bounce those and those capabilities against that top level direction to see if you have that alignment, that top to bottom alignment. You know, so it's building that big model of all of that so you can see it, because the point of architecture is to help you, you know, see your organization, and you can't manage what you can't see. So if you can build the models and you can see it, then you've got a shot at being able to manage it. You know, it's a lot, right? It's like a, you know, what was that thing, the tetrahedron or whatever? Yeah, five-sided side. Okay, so we're at time, so thank you again so much. I have to delay you a few minutes because we're not quite ready in there yet. Everybody move. So very quickly talk about tomorrow. Tomorrow's plenary session is actually very important. If you didn't know this, you're all members of the Lifecycle Modeling Organization by having come to this conference. This has been what we've historically done for now the last 5 years with the conference. And so we want to make sure that people be part of that and help us grow the organization. And so we have an election tomorrow to the new board members coming in. And we just did a fairly significant thing with the bylaws where we've added 2 new board positions. So those are also up for election tomorrow. So I'd love to have all of you here tomorrow at 9, and we'll be in this room. So so please come, and we'll also be recapping today. Okay, so thanks so much. And so I think I delayed you long enough. We should be about ready to go there. Yes, anybody can run for the board. Yes, any member can run for the board.